Hello students, so I'm Dr. Ankit Kumar. I am MD Pharmacology. So I hope you all are doing well and you are enjoying the journey of your preparation of various entrance examination. So as I have promised you that we will be providing you more conceptual and more interactive videos. So in this section, we will be discussing indeed a very important topic, that is antimicrobial resistance. Okay. Now this antimicrobial resistance, this topic covers the part of your pharmacology, microbiology, PSM and internal medicine. So question can come from any of these subjects. So enjoy the video. So let's learn about antimicrobial resistance. So let's discuss about antimicrobial resistance. So in the first section, we will see that how much big problem this antimicrobial resistance has become. And in the second section, we will see that how does a bacteria can acquire or become resistant to an antimicrobial. Now, if you talk about what is the burden of this disease or antimicrobial resistance, it is believed that this antimicrobial resistance can amount to 10 million deaths in the year 2050, which may cost you about around $66 trillion. Okay. Now, if you talk about what is the prevalence, remember no country will be spared and the worst performing nations will be Asia region. Okay. So Asia continent and the countries and the nations comprising Asia continent, which is having the largest population, will be the worst performing areas. Now, if you talk about what is the leading cause of death, it will become the leading cause of death. It may overcome, it will surpass the cancer deaths. Right now, cancer is the leading cause of death, but by the year 2050, antimicrobial resistance will surpass it and it will become the leading cause of death. So, a basic question arises that what we healthcare professionals can do to it. Remember what we can do. Remember, instead of curing an infection, the first thing is give stress on preventing an infection. So prevention is always better than cure. Second thing, vaccination. Vaccination is the greatest tool which can prevent an infection in coming future. Third point, we must remember that we must employ more number of screening tests, which could be more sensitive, more specific, so that we can employ a better diagnostic tool to confirm an infection. Most of the time, without confirming an infection, we unjudiciously prescribe antimicrobial, which is the leading cause of resistance. Okay, and we must give antimicrobial when it is truly needed. It should be given in right dose, right amount, and in the right choice. Okay, so this is the burden. So let's come to now the second part, that is how does a bacteria can become resistant to an antimicrobial. Now, if you talk about antimicrobial resistance, it can be divided into two types. Either a bacteria is inherently resistant to an antimicrobial. So this is known as inherent resistance. Okay, inherent resistance. Or a bacteria can become resistant to an antimicrobial due to its unjudicious use. Okay, so that type of resistance is known as acquired resistance. Okay, so the bacteria was not earlier resistant to an antimicrobial, but due to chronic usage of an antimicrobial, now the bacteria has acquired the resistance. Okay, now there is a big point that this inherent resistance, why it is there. Remember, the inherent resistance in bacteria is because that the antimicrobial which is binding to a target, suppose there is an antimicrobial, it is going and binding to a target in a bacteria. This target is not there. Okay, the target through an antimicrobial binds to a bacteria, kills a bacteria, that target is not there in the bacteria. So can we say that this antimicrobial will not able to kill that type of bacteria? That bacteria is inherently resistant to an antimicrobial. Okay. Now the point is, this inherent resistance is not a problem for us. Okay. This is not a problem. The reason is very simple. Why it is not a problem? Because for these bacteria, we will not be using this antimicrobial. We will be using some different antimicrobial. Okay. So let's write certain examples of inherent resistance first, like penicillin G. Okay. Now remember, penicillin G, it binds to a enzyme known as transpeptidase enzyme, and that transpeptidase enzyme inhibit peptidoglycan, which is mainly found in gram-positive bacteria. Can we say that in gram-negative bacteria, this peptidoglycan is not present? So penicillin G will not be effective against gram-negative bacteria, majority of the gram-negative bacteria, hence those are inherently resistant to penicillin G. So you will write gram-negative bacteria, especially Enterobacteriaceae family. Enterobacteriaceae family. Similarly, we will write metronidazole. Metronidazole is not effective against aerobic bacteria. So aerobic bacteria, you will write that they are inherently resistant to metronidazole. The reason is very simple. This metronidazole goes inside the bacteria and it forms nitric oxide. And this nitric oxide damages DNA. It damages DNA. But we know that inside an aerobic bacteria, there is an oxygen. In an aerobic bacteria, there is oxygen. This oxygen neutralizes or kills this nitric oxide. So this oxygen competes with nitric oxide and directly neutralizes. Hence in aerobic bacteria, metronidazole cannot produce an effect. Now, if you talk about the third one, that we will write aminoglycosides. Aminoglycosides, they are not effective against, and opposite we will write anaerobic bacteria. Why aminoglycosides are not effective against anaerobic bacteria? The reason is very simple, that these aminoglycosides, to enter into a bacteria, they require the help of oxygen pump. Now the point is, in anaerobic bacteria, there is no oxygen pump. Hence this aminoglycoside cannot enter into a bacteria. Hence anaerobic bacteria are also inherently resistant to aminoglycosides. And this, remember, this inherent resistance of a bacteria to an antimicrobial is not a problem for us. We will use some different types of antimicrobial. What is a big problem? That is acquired resistance. In acquired resistance, a bacteria was earlier sensitive to an antimicrobial, but now due to chronic use, that bacteria has acquired a resistance. And this is a very big problem for us because we have a very limited resources of antimicrobial. We are not making very new antimicrobial nowadays. Because of this reason, we are running out of options. So we will write that in acquired resistance, the resistance is developed later on. Okay. And this acquired resistance is a very big problem because we are out of options. So this acquired resistance is a great problem. So let's discuss about acquired resistance in great detail. Okay, let's make a heading, acquired resistance. Now, let's make a heading, acquired resistance. Now, if we learn about acquired resistance, that how does a bacteria can become resistant to an antimicrobial later on. So we will write that this acquired resistance, we will learn two things. You have to learn two things about this acquired resistance in great detail. The first thing is, what is the mechanism by which a bacteria acquires a resistance? Okay, what is the mechanism by which a bacteria acquires a resistance? And the second point is, what is this mechanism will produce changes in the bacteria? What changes are produced inside the bacteria through which it will become resistant to an antimicrobial? So in acquired resistance, first we will see what is the mechanism, and second thing we will learn is what are the changes it is produced. Changes are produced inside the bacteria which will lead to acquired resistance. Now let's talk about first the mechanism of acquired resistance. Now, remember, a bacteria can become resistant by acquisition. A bacteria becomes resistant by acquisition of a resistant gene. Okay, a bacteria becomes resistant to an antimicrobial by acquiring a gene which will confer a resistance, and because of this reason it will produce some genetic changes. It will produce certain genetic changes inside the bacteria, and that genetic changes will confer resistance. Now let's see a basic question, that how does this resistant gene is acquired by the bacteria. Okay, how does this resistant gene is acquired by the bacteria? So this resistant gene is acquired by the bacteria in two ways. First we will write, either it is due to vertical transmission of a gene, either it is due to vertical transmission, or it is due to horizontal transmission. Okay, horizontal transmission. Okay, now let's see what is the difference. Vertical means we are going from up to down, this means vertical, and horizontal means we are going sideways. This is what horizontal and vertical word means. In vertical transmission, there is a bacteria. Okay, there is a bacteria. This bacteria will give its resistant gene, to its progeny. So can we say that this bacteria is the father of a progeny? So let's call this bacteria as paternal bacteria. And when this bacteria will divide, the resistant gene which is present in the bacteria will come to the progeny. So it will come to the progeny. So this is how this resistant bacteria will keep on multiplying. This is known as vertical transmission, up to down. Okay. Now in horizontal transmission, there is a bacteria. Okay, there is a bacteria, and this bacteria will acquire a gene from outside. Okay, so first let's discuss about the examples of vertical transmission. So if you talk about the examples of the bacteria which have become resistant, with course of time they have acquired resistance, are, the first one we will write, either it is due to spontaneous mutation. We'll write, either it is due to spontaneous mutation. Due to spontaneous mutation, this paternal bacteria has its own genes have been modified. That means its own gene have been now modified. This is known as spontaneous mutation. So it's a kind of vertical transmission. Now this spontaneous mutation could be of two types. Either this genetic change or these genes have been modified in single step. So this is known as single step mutation. Or it is due to multiple step mutation. Now, in single step mutation, remember, a bacteria will become suddenly resistant. And here the bacteria will become gradually resistant. So let's write the examples of those bacteria. The first bacteria is Enterococci or Enterococcus. Okay. Now Enterococcus has become resistant to a aminoglycoside known as streptomycin, and it has become resistant through single step mutation or single step spontaneous mutation. Similarly, we will write E. coli. E. coli have become resistant to rifampicin because of this reason. And lastly, we will write tuberculosis. TB bacteria has become resistant to isoniazid and rifampicin. Now this is a very important point that you must remember. And this type of TB bacteria which has become resistant to isoniazid plus rifampicin is also known as MDR-TB. This type of TB bacteria is known as MDR-TB. Now let's talk about the examples of multiple step mutation. We will write like resistance against erythromycin, chloramphenicol, and lastly tetracyclines against various bacteria are due to multiple step mutation. Okay, so this is how a spontaneous mutation which occurs in cases of vertical transmission. Now let's come back to this horizontal transmission. Okay, a basic question arises that, sir, this bacteria acquires a resistance gene from outside. A basic question arises, sir, that from where? So let's make a heading horizontal transmission. Okay, horizontal transmission. So in case of horizontal transmission, a bacteria acquires a gene or a resistant gene from outside. Okay, so let's see from where this bacteria can acquire a gene. On this basis, from where the bacteria is acquiring a gene, this horizontal transmission can be divided into three types. The first one you will write as conjugation. Okay. Second is transduction. And lastly, transformation. Now, what is the basic difference between conjugation, transduction and transformation? Let's understand this point. In conjugation, this bacteria acquires a resistant gene from another bacteria. So here the bacteria will acquire a resistant gene from another bacteria. Okay. In transduction, a bacteria will acquire this resistant gene from a virus. And transformation, we will write a bacteria will acquire a gene from environment. This gene or DNA is lying freely in the environment. From where freely in the environment? Suppose the bacteria which is in vicinity of this bacteria has become dead. Okay, and its DNA is lying around there. This bacteria can directly uptake this resistant gene containing DNA directly. This is known as transformation. So if I'll repeat again, in conjugation, bacteria acquires a gene from another bacteria. In transduction, a bacteria acquires a gene from a virus. While in transformation, a bacteria acquires a gene directly from the environment. Now we will write that this conjugation is the most common method of acquired resistance. Okay, so the most common method of acquiring a resistance is conjugation, and this transformation is the least common method overall of acquiring a resistance. Okay, now let's talk about conjugation in more detail. Okay, now in conjugation, let's make a heading conjugation. In conjugation, as we know, a bacteria is acquiring a gene from another bacteria. Okay. Now remember that in the resistant bacteria, there are two sets of genes. One is a very big set of gene, which is also known as circular DNA. This contains gene. And there is a very small gene, which is known as plasmid. Okay. Now, this resistant bacteria, it is having a plasmid. Now, how does this plasmid enters into another bacteria? So, this resistant bacteria, it replicates its plasmid. This plasmid becomes 2. And now, this plasmid can be given to another bacteria. This plasmid enters into another bacteria. Okay. Now the plasmid which is entering into a different bacteria, this plasmid is also known as episome. This plasmid which is going to another bacteria is known as episome. And this plasmid contain genes which can make this bacteria resistant to an antimicrobial. Okay. So it is sometime conjugation is also known as episomal. It is known as episomal transfer of resistance. Okay. Episomal transfer of resistance, because we know episome is the plasmid. Now this conjugation, remember, is also known as sexual reproduction in bacteria. Okay. This conjugation is also known as sexual reproduction in bacteria. So till now we used to believe that bacteria, they divide asexually. Okay. So we know now that bacteria among themselves can change or transfer its gene or genetic material. Conjugation is known as sexual reproduction in a bacteria. Now let's see what are the examples of those antimicrobial in which conjugation have developed for a bacteria. We will write like in typhoid. Typhoid bacteria Salmonella typhi now have become resistant to chloramphenicol. And this is a classical example of through conjugation. Okay. Secondly, we will write streptomycin. And E. coli have now become resistant to streptomycin through conjugation. And lastly, we will write against penicillin. We will write Haemophilus and gonococci. Gonococci and Haemophilus. They have become resistant to penicillin through conjugation. So among this list, try to remember the last option, that is Haemophilus and gonococci have become resistant to penicillin through conjugation. Now let's come to the second one, that is transduction. In transduction, a bacteria acquires a resistant gene through a virus. So this virus is carrying a resistant gene. Now this virus, which is donating its resistant gene to a bacteria, this virus is also known as bacteriophage virus. Okay. This virus is also known as bacteriophage virus. So again, it's a very important line that you must remember. So the virus who are entering into bacteria and giving their gene are known as bacteriophage virus. Now the examples of these bacteria which have become resistant are Staphylococcus aureus and Streptococcus Okay, Streptococcus and Staphylococcus. Now let's come to the last one, that is transformation. In transformation, as we have discussed, the bacteria can directly uptake the resistant gene from the environment. Okay, directly from the environment. Now, the examples of transformation, we will write that resistant to penicillin in cases of Neisseria, like Neisseria meningitis, Neisseria gonococci, and we will write pneumococci. They have become resistant to penicillin through acquisition of a virus which transfer its resistant gene into a bacteria. Okay. Now, this is all about how a bacteria is acquiring a resistant gene through spontaneous mutation, which is known as vertical transmission, or from outside, that is known as horizontal transmission, which was further divided into conjugation, transduction and transformation. Now, a second basic question arises that when a bacteria acquires this resistant gene, what changes are produced which can make this bacteria resistant to an antimicrobial? Okay. So the second point we will write, what are the changes this resistant gene will produce? So you will write changes in bacteria. Now we will write a point that when this bacteria acquires this resistant gene, this gene will produce a resistant protein. This gene will produce a resistant protein, and this resistant protein will make a bacteria insensitive to that antimicrobial. So this resistant protein, let's see what are the different types of resistant protein a bacteria can form, which can make a bacteria resistant. So we will write that this resistant protein could function inside the bacteria in many ways. It can function in the bacteria in many ways. Let's say first point, this resistant protein can reduce the entry of antimicrobial. This resistant protein can reduce the entry of antimicrobial. Suppose this is a bacteria. Inside in a bacteria, remember, there are certain channels. These channels are known as porin channel. Through this porin channel, an antimicrobial enters into a bacteria, and these porin channels are made up of proteins. Suppose this bacteria is now forming abnormal protein. This abnormal protein is known as porin protein. So if this bacteria is forming abnormal type of porin protein, an antimicrobial cannot enter into a bacteria. Okay, and this mechanism is also known as that the drug or an antimicrobial will become impermeable. So bacteria can develop resistance to make a drug impermeable. So we will write just this point, impermeable. Okay. The classical example of drug impermeability we will write is that there is a microbe known as trypanosoma. Trypanosoma brucei. Trypanosoma brucei, remember, it causes a disease known as sleeping sickness. For this Trypanosoma brucei, we use a drug millarsoprol, and we use a drug pentamidine. Now this trypanosoma has become resistant to millarsoprol and pentamidine. Through which mechanism? Through formation of abnormal porin channel. Okay. Now let's talk about the second mechanism of resistance. That second mechanism of resistance is known as efflux transporter. Efflux transporter. Okay. It is known as efflux transporter. Now what does it mean? Suppose this antimicrobial has now entered into the bacteria. This bacteria now has synthesized an abnormal protein. That abnormal protein function as efflux transporter. Now efflux transporter, it will hold this antimicrobial and throw this antimicrobial outside. It will throw back this antimicrobial outside a bacteria. So this is known as efflux transporter. Okay. So this is also known as drug efflux. So that antimicrobial will be thrown outside. The classical example of the bacteria which are developing this kind of resistance we will write is tetracyclines. Against tetracyclines, you will write antimalarials. You know various antimalarials like chloroquine, quinine, mefloquine, etc. So against antimalarial, a bacteria develops a resistance through efflux transporter. This is a very important point, and rarely by fluoroquinolones. Okay. Now let's come to the third one, that is altered target. Third one is known as altered target. Now altered target means, suppose you have given an antimicrobial and this antimicrobial bind to its target, and binding to its target kills a bacteria. this bacteria now has formed an abnormal type of target through which an antimicrobial cannot bind. Okay, so this mechanism is also known as drug tolerant. Drug tolerant means that this antimicrobial will not able to bind to its target because now this target have been modified. The classical example that you must remember is against, we will write drug tolerant. The classical example we will write is MRSA. Drug tolerant we will write MRSA. MRSA stands for methicillin resistant Staphylococcus aureus. Okay, methicillin resistant Staphylococcus aureus. So this is drug tolerant. We will write certain other examples of drug tolerant also. So let's write certain other examples of drug tolerant. So the first example we have already written is MRSA. MRSA stands for methicillin resistant Staphylococcus aureus. Okay, normally this Staphylococcus aureus goes inside the bacteria and it binds to a protein known as penicillin binding protein 2A. Penicillin binding protein 2A. Now this Staphylococcus aureus now is forming or synthesizing some abnormal type of penicillin binding protein 2A. Hence this penicillins like methicillin cannot bind to this penicillin, cannot bind to this Staphylococcus aureus abnormal type of penicillin binding protein. Okay. Similarly, the other example you will write fluoroquinolones. Fluoroquinolones in a bacteria inhibit an enzyme known as DNA gyrase. Now this bacteria have started forming an abnormal type of DNA gyrase to which fluoroquinolone cannot bind. So its target has been modified. Similarly, we will write other examples like against macrolides. In macrolide, they generally bind to ribosomes of the bacteria. So those ribosomes have been modified. Okay. Fourth, we will write all anti-HIV drugs. Against all anti-HIV drugs, the resistance have developed due to altered target. Okay. Fifth, we will write albendazole. Okay. Albendazole binds to microtubules of a bacteria of a helminthic infection. So these microtubules have been modified. So this is the example of drug tolerant. Now let's come to the last mechanism that is known as enzymatic degradation. Enzymatic degradation. Now enzymatic degradation means suppose there is an antimicrobial. This antimicrobial enters into a bacteria, and when this antimicrobial enters into a bacteria, bacteria degrades this antimicrobial. It is degraded by enzymes. Agreed? So this mechanism is also known as drug destroying. This is also known as drug destroying mechanism. Okay? So enzymatic degradation occurs against the bacteria. We will write the mnemonic A, B and C. A for aminoglycoside. Okay. A for aminoglycosides. B stand for beta-lactams. Because against beta-lactams there is a formation of an enzyme beta-lactamases. And lastly, chloramphenicol. Chloramphenicol. Okay. Against these three antimicrobial, the bacteria have become resistant due to formation of degrading enzyme. So this is overall how the bacteria become resistant to an antimicrobial. And indeed, it's a very important topic. And that important topic you must revise by whole heart. So I hope you have understood the whole concept of antimicrobial resistance. So thank you very much for listening to this video.